Today we're going to take a look at a long forgotten yet pretty interesting piece of computing history. This is the Sun JavaStation. The JavaStation was released by Sun Microsystems in 1996 and was marketed as a lightweight, diskless network computer designed purely for running Java Applets. The system runs Sun's proprietary JavaOS operating system, which was purpose-built for use with the JavaStation. The vast majority of this operating system, including the whole UI, is built purely in Java. Underneath this sits a very small layer which just consists of enough to boot the system and run a JVM. So this is pretty much as close as you can get to a fully Java operating system. This system was released right at the time that Java was massively being promoted by Sun Microsystems. The JavaStation was intended to be used in applications where the machine would only run a small number of very specific applications, such as information kiosks, call centers, or customer service desks in places like airports. As the system is diskless, it requires a server to boot and can't really do anything without this. All configuration is also managed by the server. This means that the individual Java stations can easily be installed and replaced without requiring any local configuration. This particular model is the first version that Sun released, affectionately known as the Mr. Coffee. It has a 110 MHz Microspark 2e CPU and 32 MB of RAM. This hardware is similar to what was previously used in Sun workstations. However, by 1996, that had already been superseded by the more modern 64-bit UltraSpark line. The whole thing is built inside a Sun Unidisk enclosure, which Sun was already using to house external drives for use with their workstations. Later on in the system's lifespan, a second version was released which had a much more stylish case. Other models and prototypes were also developed, however these were never really sold to the mass market, so they're pretty hard to find nowadays. Now let's take a more detailed look at this hardware. So here it is here, it's fairly small. On the front we have the JavaStation name, sort of branding, a Sun Microsystems logo, as well as this big coloured Java logo. The whole thing's a sort of quite nice dark grey colour. However, the colour of the machine changed throughout its generations, so they also did other versions in the exact same case which were more sort of beige colour. However, this is in sort of nicer looking grey style. On the top there's also this sort of nice black and white Java logo. They're really sort of trying to push the Java branding on this thing. Looking around the side, we can see we have ventilation on both sides. This one also has a speaker mounted on this side as well, but there isn't really a grill for that. But that's the ventilation there. These are both air intakes. And then finally on the rear, we can take a look at the I/O. So now let's go through the rear I/O. So we have a pair of PS2 ports for the keyboard and mouse, a VGA port for the monitor, a standard 10 meg Ethernet connection, a serial port, which can also be used as a serial console, and an audio output. At the top we can see we have a latching power button to switch it on and off, an IEC connector, and a fan that pulls air out, which is used to both cool the power supply and the main machine. This sort of I/O is interesting for a Sun machine of this period. Their workstations at the time would have used 13W3 monitor connections, and then a special proprietary serial protocol for the keyboard and mouse, where the mouse plugged into the keyboard, and the keyboard then connected into the machine over its own proprietary connector. However, this machine uses the standard PS2 and VGA connections. This sort of reinforced the idea of this machine being a cheap, low-cost device, where you can use standard PC peripherals rather than having to buy expensive Sun proprietary hardware for it. So now let's pop the top off this and see what's inside. So it's fairly easy to take apart. On the back we've got another one of these sort of Sun lockable screws, where there's a screw in here, but it's surrounded by this metal casing that you can put a padlock through, which allows you to secure the machine down so it can't be stolen, as well as prevents the machine being opened while it's blocked. So we can just take that screw out and then get inside. So, take that out. Like that. And then finally there's just a pair of little plastic clips on the side, sort of here. So you just need to press these in and then lift the top off. That. There we go. Now let's take a look at the hardware. So now here we are inside, so let's take a look at the layout. So here we have the motherboard, which is mounted in the bottom of the case, with the RAM, CPU, a few other components over here, and then more under the power supply. Then we have the power supply here, which sits above the motherboard and is sort of housed here. So let's go in a bit closer and look at all the components. Here we have the CPU, which is the Microspark 2. This is 110 MHz, as defined by the 110 here, and as you can see, it's just soldered directly to the motherboard. On the higher end Sun workstations, they use the same sort of CPUs, but they were actually socketed, but on this they've just soldered it because they're not expecting you to ever want to upgrade the processor in this. There's no active cooling on the processor. Instead, it just has this little heatsink here, which is almost like 3 metal discs that are all stacked on top of one another, and then it relies on the airflow through the case from that rear fan to keep the processor cool. Next we have the RAM, where we have 4 slots that can each take up to 16 megs of RAM. This means that the JavaStation can take a total of 64 megs of RAM. This model has a pair of 16 meg sticks, so we have a total of 32 megs, and we can just take these out. And these are standard 72-pin SIMs, so there's the standard RAM you'd have in PCs from the time period. This again made this low cost. It meant you didn't have to buy proprietary Sun RAM like you had to do with workstations. You could just add standard off-the-shelf RAM. Now while if you think of this as a thin client, it seems a bit weird wanting to upgrade the RAM, but bear in mind that while this machine did require a server to boot and run, it did actually run the Java applications locally, which meant that if you had a really intensive application, you could actually run out of RAM on this, so upgrading it was a good idea. So that's the RAM in there, so we have 32 megs. Behind this we can then see we have the LED, just the power LED, which connects to the motherboard over this little connector here. The LED is located here, and there's a little light pipe that brings it out to the front of the case. Now in this corner here, we then have a speaker because this machine does have built-in sound capability, and then the connections from the power supply. The power supply connects mostly over a standard 4-pin Molex connection to the motherboard. However, there's also this 2-pin connection here, which I'm not sure what it's for because it's quite thin wires. I'm wondering if there's some sort of feedback to the power supply or allowing it to sense the motherboard state. So both those wires go out to the power supply. Under here we then have a standard crystal audio chip, which was also fairly common in Sun machines from this time period. In this corner we have the standard issue Sun Nvram chip, which also contains a built-in battery which retains the settings. As usual with machines like this, the battery is now dead due to its age, so the machine's lost its configuration settings. This means that in order to use this machine nowadays, I have to manually enter commands over the serial console in order to set the appropriate configuration to get it to boot. So we'll take a look at this later. You can technically resolve this issue, but you have to sort of cut into this chip to access the battery terminals and then wire on a new battery. So it's quite an involved process that does have a reasonable risk of damaging the thing. So for now I'll just leave it intact and we'll just have to set the configuration manually. There's also a few jumpers around the machine which are used to set different configuration options such as how it would boot up, put it into various debug modes, configure the serial terminal, things like that. So there's quite a few jumpers which are all fairly well documented. The rest of the motherboard is covered by the power supply, so what I'll now need to do is take the machine apart, get the power supply out and see what's hiding underneath it. So I've now disassembled the system and it wasn't really that painful to do. All I really had to do was remove a single screw from above the power supply, take the retaining screws out from the VGA and serial ports, and then remove the speaker because it got in the way a little bit. Then you just need to slide the whole board forward and it just lifts out with the power supply attached to it. So now let's take this board, get the power supply removed, and see what's underneath. So now here we have the underside of the board where we can see the footprint from the CPU and RAM, and all that's holding the power supply in now is just these 2 screws here. So we just pull these out carefully, we can then get the board out on its own. That comes off, and one more screw here. So overall the system isn't actually too painful to work on. There we go. And now it should be a simple case of sliding the board up a little bit and then lifting it off like that. So that's power supply there. Now let's take a look at the part of the motherboard that was hiding underneath it. Now here we can see all those components that were previously hidden by the power supply. So if we look through these, here we have the standard BT RAM DAC which does the video, so that will be connected up through to the VGA port. There's then this level 1 chip, which the model number is LXT901PC. This is a 10 meg Ethernet controller, so that will connect up to the Ethernet port and give the machine the Ethernet capability. We've then got this little chip here that's obviously got something to do with the serial port, and then we have the audio output there, which will connect back and go into this crystal chip here. Finally, over on the left hand side, we have this Super I/O chip from National Semiconductor, which is the model number PC87303. This chip's got quite a lot of functionality. It can provide floppy disk controllers, it can do real-time clocks, it has dual UART, it supports parallel ports and IDE interfaces, but I think all they really seem to be using it for here is just to provide the 2 PS2 ports. They may be using it for the serial port as well, but it's a bit sort of far away from the serial port for that. But yeah, this chip is providing the PS2 ports and possibly has something to do with serial as well. I'm not 100% sure on that. Around this area there's a reasonable bit of corrosion, but I don't think it's anything to do with the battery. There's not really much corrosion around the battery area, and the battery itself is sort of potted and sealed within this chip, so it shouldn't leak out, and I've never seen one of these leak before. Most of the corrosion is actually on the external ports, like this VGA port here and the PS2 one, and then there's a little bit on some of the components in here. So I'm guessing this machine is just maybe stored in quite a harsh environment over the years, and it's maybe been damp, like it's maybe been in a sort of just untreated brick wall environment, and the back's been sitting against a wall or something and it's got a bit damp. So I'm hoping it's not going to get any worse, and the machine seems to work absolutely fine as it is. So I might try cleaning it up a little bit with alcohol, but it doesn't seem to affect the functionality. And given it doesn't seem to be the battery, hopefully it's not going to get any worse. So there we have the JavaStation completely disassembled. Now let's get it all put back together and fire it up and see it running. So now here we have the full setup we'll be working with. So what we have is this standard VGA monitor plugged into it, a PS2 keyboard, which for people wondering is an IBM Model M2. So it's a buckling spring Model M, but it's a lot thinner and lighter than the full size one. And then a standard PS2 ball mouse. So they're all plugged into the JavaStation. What we then have is an Ethernet cable that's connected into one of my Ethernet ports, and that's on a dedicated VLAN, so it's an isolated network that goes between that port on the wall that the JavaStation is plugged into, all the way through to a virtual machine running on my PC. That means the network's completely isolated from the rest of my network. It's only got the server and the JavaStation on it. This is because the JavaStation uses a lot of outdated network protocols to boot, and it's therefore a bit tricky to get it to work on a network when there's other things running on it. The server then provides all the services that are required to make the JavaStation boot up, which we'll go through in a second. So what we'll now do is we'll take a look at how we boot this. As I mentioned previously, due to that battery failing, the machine's lost all of its settings that should be in its Nvram, which means that it won't boot by default. It'll boot up with a MAC address of all zeros, and then the switch will refuse to forward the network traffic, and it won't actually be able to boot. Therefore, what we have to do first of all is set those settings over the serial console. So I've got this old laptop here, which is plugged in with a standard null modem cable into the serial port on the back of the JavaStation. When we start it up, it'll start up to the serial console, where we can issue a series of commands to set all the appropriate settings. Then we'll be able to reboot it, and it'll start up from the network like normal. So now let's switch the JavaStation on, and we'll see it boot up over serial. So there we go, so we're now getting a message saying incorrect configuration checksum, setting NVRAM, various things like that, probing CPU. But as you can see, it's now failed and it says cannot open boot device. So we now need to issue a series of commands to set the appropriate configuration data, which I've got handily in Notepad over here. So hopefully I can just copy and paste some of these. I'll have to do it in smaller batches because pasting it all at one go doesn't quite work. But if we just issue all these commands, this will set the MAC address to a sensible value that will then work on the network. So hopefully, there we go. So that's now set the MAC address on the system. So now all we need to do now is when we type reset here, the machine will reboot and start up from the network. So before we boot the system, let's talk a little bit about how this machine network boots. As you can see from some of the names here, this uses a lot of very outdated network protocols. The first thing it does is it sends out a reverse ARP request to attempt to get an IP address. Effectively, the machine sends a broadcast packet to the entire network that just shouts out its MAC address and waits for a machine to respond back and give it an IP address. Once the machine has an IP address, it then connects back to the same machine that gave it the IP address and uses TFTP to transfer a file that contains part of the JavaOS operating system. Once it has this file, it then starts to boot. The next thing it does is use NFS to transfer the rest of the operating system over, which is a much larger file, and starts booting that. Once that's loaded, it then makes a DHCP request, which uses to get another IP address. This time this is the IP address the machine will use once it's booted. It also uses DHCP to get other options, such as the time server, the NIS server, as well as various configurations such as how the logins work, whether it allows guest logins, how it mounts home directories, and more features like that are all set over DHCP options. You can also set a special DHCP option that provides a URL to the JavaStation, which will make an HTTP request to and download a further, much larger configuration file. Next, the system will make a time request to get the date and time. Finally, when you attempt to log in, it uses NIS to check the credentials that are given, and then it'll let you log in. Once you're in the system, everything else, including loading applications, is all done over HTTP. Okay, so now we're ready to boot. So what I'll do is I'll show a live capture of Wireshark running so we can see what's going over the network as the machine boots, and I'll attempt to narrate what's going on. So what I'm now going to do is issue the reset command on that laptop, which is just sitting off camera, which will cause the machine to boot up. If the machine was working properly, this is the effect, exactly what you would get from switching the power on switch on at the back. So this is effectively the full boot process from switching the machine on fresh. So we're now going to start it up and we'll watch the machine boot. The machine's now restarting. In a second the monitor will come on and it'll start booting up. So that's the monitor now on, and the machine will now begin to boot. So it gives this error, which I'm not really sure why it does it, but now it's done the RARP request, it's downloaded that file over TFTP, and now it's using NFS to download the rest of the operating system. So we just need to wait for it to download that, which does take a little while because it's only got a 10 megabit Ethernet connection, but it is now booting up. So it's now reloaded and it's stopped loading over NFS. The system has now made a DHCP request to the server to get some configuration, and now that it's done that, it's finally booted up to this login screen. So let's go in closer and take a look at it. Now here we have our first glimpse of JavaOS by looking at the login screen. So it's got this sort of fancy background that's sort of all animated with different coloured sort of stars moving around, and then welcome to JavaOS with the old-fashioned Java logo. Enter username and password to continue, and then you can log in here. You could have also set DHCP options to either bypass this login completely and log in as a guest, or you could also have the option to have a guest login button as well as the main login screen. But we'll just do a normal login here, so we'll log in with username and password. And then in Wireshark, you'll see this make the NIS request to the server to check authentication, and then we'll log in. And there we go, it's made that request, and now we're into JavaOS. So the first thing we see when we log in is this sort of welcome to hot Java screen. You could set DHCP options to configure what the machine did on login, so usually it would open up a predetermined application or some sort of launcher that listed applications that were available. But this one just does that welcome screen, and then it loads up the hot Java web browser. So now let's go in closer and take a look at this running. So now here we're in the hot Java browser, so we can take a look at what it can do. So it first of all loads up this welcome screen, which sort of talks about things you can do. So it tells you about holding shift to open up the page in a new window. Obviously there's no tabs in this browser. Click on the title to type in a URL. So it displays the title here, but clicking that pulls up a URL bar. And click on me for getting started. So we'll take a look at the getting started docs first. So that loads up, and it's just very basic information about how to load web pages and use a web browser. So open a URL in hot Java, navigate the web in hot Java, etc. So we go into that. And it's a sort of paginated system here. So that is the sort of main sort of getting started guide. I will admit I don't actually yet have this hooked up to the internet because it's on this private network, and I've not yet set up any sort of routing to the internet through that. So we can't try and load web pages, but to be honest, it would just be a case of lots of very broken, badly rendered web pages and some that probably wouldn't work at all. What's much more interesting with this is to look at the JavaStation specific things that this does. So if we go up to the view menu, we can go down to monitor, and this has pages we can look at to see what the machine's doing. For example, there's this progress plus, which lets you look at how it's downloading and rendering pages. So this will sort of show what assets are being loaded at what times. Next up, we get another page which is print jobs. So you could actually connect this up to a printer. This would most likely be over the network, and this would list all the print jobs on the system. Obviously, there's no printer here, but that's what it would do. And as you can see, it's mentioning version 1.7 JavaOS. The other thing to note that's quite interesting here is that even though these pages themselves are all HTML, these widgets in the pages are all Java Applets. So all these options, like these checkbox and stuff, are all done through a Java applet. It feels almost weird using this after using Java on more modern systems, because it just works. You load up a page, the applet just runs, and it just, you can use it. Whereas on a modern browser, you have to, you get all the pop-ups of, this is about to run Java, are you sure? And accept all the security warnings, all the certificate errors and stuff you inevitably get. I mean, I was working on an HP Switch a couple of days ago, and it was, I think, to load each web page, you got about 10 Java alerts popped up. Whereas on this, you load a page, the applet just runs. I mean, that's mainly because this is before Java became a massive security vulnerability, but it feels surreal how sort of just Java just loads really quickly. So that's the print job monitor. The next page we have is memory, which is quite interesting. So this is another Java applet that gives us a visualization of the memory of the system. So as we can see, the green is objects, black is free space. There's some more memory down here that's reserved. Bit vague here, red reserve and yellow reserve. Don't quite know what they both mean, but there you go. And then up here you've got mallocs, which are at the top of the memory, and then there's all the free memory here. You then get the sort of readings here, so you can see that's 24 megs of RAM total, because there's some reserved, and then 17 megs free. There's also pretty interesting options, so you can zoom into this apparently, and you can zoom out, and you can sort of move up and down to investigate your memory, which is a pretty interesting idea. But yeah, this is a sort of way to visualize memory usage. You can also really tell you're inside a Java application when you have a nice little perform garbage collection button that you can click. That locks the whole system up for a bit and clears out some of the memory. So you can definitely tell it's Java. And the key thing with this is this entire operating system's Java. There's a very basic layer that loads up to start a JVM, and everything that runs on top of that is based in Java. So this whole web browser, the whole environment here, is fully Java based. The final thing we can look under the monitor thing is this threads one, which lists all the threads running in the system, which you can see there they all are. Now you can see everything is done by sort of standard sort of dot path name, don't know what you'd call it, the sort of hotjava.applets.imagemap sort of naming for all the classes. So it's just standard class names for everything. And there you go. So that's all the threads in the system. And you can, in theory, kill them, but I'm not going to do that because that is how I will inevitably break the system completely. And again, this whole thing is another Java applet. So now let's take a look at this running an application that would actually be used in a production environment. And that is Coral Office for Java, because that was something that was actually released for this system. So because it's loaded over the network, the way you load applications is just like loading any web page. You go to a URL and it serves the application. And it just happens to be, in this case, it's more of a Java applet than a regular HTML application. So we go to the IP address. So the IP address is just going to be the IP address of the server that this is booting from, because that's where I'm hosting this. 192.168.23.1. And there we go. So this is just an HTML file that I put that just lists the applications. So from here we can go to Coral Office for Java. Or in fact, what we can actually do is we go to Office. We can see this welcome page that it renders, which shows the actual, almost like an advert for Coral Office for Java. So this is a sort of welcome screen to the application, which describes all the features it has. And now we can go down here to Run Coral Office for Java now. So let's click that. And what you'll notice here is how long this takes to load. It's quite a big application, and it's only running over a 10 meg Ethernet connection, and it takes ages. And it's definitely not the server, because the server's running on a brand new modern day PC. So it just takes ages to load over the network. So I'm just imagining back in the day where you've got a much weaker server than I have here, and loads of people accessing it, how slow the system must have actually been. But here it is. Here we have Coral Office for Java. So we won't go into too much detail, obviously, because it is a bit boring, but we can see it lists some applications. We have Wordperfect, Quattro, which is spreadsheets, and presentations. So for example, we can open up Wordperfect. Again, it takes ages to load. You get this sort of weird flickering loading bar in the corner. And it's still loading, it's still pulling data over HTTP that I can see on Wireshark. But eventually, we'll have Wordperfect running on the JavaStation. And there we go, that is an Office suite. So the idea is you'd use this, you could do that, and then you can, in theory, you can change things like fonts in here, so you can increase the font size. And change colour even. But it is worth noting how slow this is. Like, it's Like you can see, it's almost like lagging out when I'm trying to do things. Oh, 3 fonts, they're treating us here. But it does just really lag out, it's quite slow. And that was one of the main complaints people seem to say with these machines when they're being used in production. It's just that they were really sluggish to use. But that's a quick look at the sort of Wordperfect side. We can also click here to go back to the desktop and load other applications. So we can try and load Quattro, which again will probably take ages to load while it downloads it over the network. So let's wait for that wee bit. There we go, we finally loaded a spreadsheet, which actually looks a bit better than the word processor. It looks a bit sort of more attractive, but yeah, in theory, we can probably use this as a spreadsheet. I've not used Quattro before, so I'm going to have to try and guess from, obviously, knowledge of Excel, but let's see. Okay, that didn't quite work, but, what? A1. There we go. I used a spreadsheet, yay. Yeah, so that's the spreadsheet application. The final one we'll quickly take a look at is the presentations, which are a little bit more interesting. So we can open this up. And it does just take ages to load these. It must have been absolute hell trying to use these in a production environment and try and get work done. There we go, there's presentations where there's a bit more flexibility. For example, you can do things like change the slide background where it's giving us a list of nones, okay. Do gradient, you can do solid colours, so we can, I don't know, make a little gradient up ourselves. That looks absolutely terrible, but okay, cool, try that. Oh, here we can make an absolutely horrific looking presentation. So there's our presentation we've made. So now there we have our terrible slide. We can now attempt to show the slideshow. So we can go to there and go play slideshow. Play. There we go. And there we go, it's loaded up. It looks absolutely dreadful. But one thing that's quite interesting is any window that's launched by a Java applet will contain this big message here. It says warning applet window. I think this is obviously an early security measure so that an application can't pop up a window that looks like it's part of the operating system, which they could really do. This does mean that any presentation you did in this Office suite would have this big warning at the top saying warning applet window at the top, which is a bit weird. But yeah, that is the presentation side of this. The final application we have as part of this Office suite is called Info Central, which appears to be some sort of calendaring and address book functionality. I've already loaded it up because it took an absolute age to load, but we're in here where we have a sort of fairly basic sort of calendar system where you could create an appointment, sort of resize it and things like that. So it's got basic calendaring, flip through the years and stuff like that. It's got built-in address book as well, so you could obviously add contacts to this. And it's also got built-in email. So we're clicking onto this and it just asks us to set up POP3 and IMAP servers, which I'm not going to do right now, but that would be the email functionality. I noticed that also with these, all of them have this warning applet window message at the top of them. Because these are all individual Java applets launched from the main application. So let's close out that. So there we go. That was Coral Office for Java running on JavaStation. And what this really reminds me of is like a really terrible version of a modern Chrome OS Chromebook. Because it's a very similar idea. The machine itself is completely independent, doesn't really have its own configuration. All it has really is a web browser. All applications are loaded as web pages and run on the machine, and then data is stored on the remote server. The only real difference is that this machine uses Java applets instead of modern HTML5 and JavaScript applications, and this is completely horrifically slow and borderline unusable, whereas at least a modern Chromebook can be used for actual work, whereas this thing would just be incredibly frustrating to use. But the overall idea of having a machine that just loads a web browser and runs applications within that a Chromebook is nowadays, seems to be, this seems to be a very early precursor to that. So now because JavaStation is completely diskless and therefore has no local storage or no local configuration, there's no real need to shut it down or even a way to shut it down. When you're finished using the machine, all you do is just power it off at the back. Like that. So there you go. That was a look at the Sun JavaStation. It's definitely a very interesting machine. It's something I'd never really heard of before, and there's not much information about it online. In fact, setting this up was an absolute nightmare, because there's very little documentation, so trying to work out how to create a boot server for this was very difficult. Effectively, I had to sit using Wireshark to sniff the network traffic coming out of it, and look at everything that it tries to do during the boot process, and use that to reverse engineer what the server should be doing, and then set the server up appropriately. But it works, and I now have a fully working, fully booting JavaStation. So yeah, it's a definitely very fun system to work with, completely unique, never seen something like this before, and it's just a bizarre, long forgotten piece of history. So there we go. Thank you very much for watching.